So last time we looked at the definition of an exothermic reaction, and we said that an exothermic reaction is a process that is accompanied by production of heat, energy, while an exothermic reaction is a process that is accompanied by absorption of heat. So we said that when a reaction is taking place, if heat is produced, then we call it an exothermic reaction. If heat is absorbed, then we call it an endothermic reaction. Now today we'll be looking at bond breaking and bond formation. And we start by saying that during a chemical reaction, bonds of reactants are broken to form individual atoms. The atoms then rearrange to form new bonds, forming products. So what you're supposed to know here is that when a chemical reaction is taking place, there is bond breaking and bond formation. The bonds of the reactants are broken, and then the atoms rearrange themselves to form new bonds, and new bonds form what you call the products. A very important point that you're supposed to know is that when bonds are being broken, energy is absorbed. Thus, bond breaking is an endothermic process. Remember, we said that when energy is absorbed, the process is endothermic. And we're saying when bonds are being broken, energy is absorbed. Thus, bond breaking is an endothermic process. The energy are therefore, of course, given a positive sign. We said that when endothermic reaction takes place, the energy is positive, absorption positive. Energy is being absorbed, positive. Now, during bond formation, energy is released. Thus, bond formation is an exothermic process. The energies are therefore negative. Remember, we said that in an exothermic reaction, the energy is negative because energy is being lost. There is a reduction in energy. Therefore, it is negative. It is given a negative sign. Now, let me explain a little bit what we are saying here. And I'll start with a very simple reaction. Assuming chlorine is reacting with hydrogen gas to form, what is formed is hydrogen chloride gas. And when you balance the equation, you should put a 2 there to balance the number of atoms. Now we have 2 hydrogen atoms on both sides and 2 chlorine atoms on both sides. Now, chlorine is a diatomic molecule. What you mean by a diatomic molecule is that 2 chlorine atoms combine to form a chlorine molecule with 2 chlorine atoms. And the atoms combined by sharing of electrons. Remember, chlorine has 7 electrons in the last energy level. So it shares the 7th electron, and this one shares the 7 electrons to form a pair of electrons, so that now each of them now has 8 electrons in the last energy level. That is what we call a covalent bond. The same thing with hydrogen. Hydrogen is also diatomic molecule, shares electrons to form a hydrogen molecule. Now, when this bond is broken, we are left with individual chlorine atoms, now each with one electron, therefore it becomes highly reactive. Same thing with hydrogen. We are left with, we have hydrogen, 2 hydrogen atoms. Now because the bond is broken, the bond that was joining the atoms together is broken. Now when that bond is broken, the atoms, we are left with individual atoms. Which are very reactive. Now what happens? We said that there is rearrangement of the atoms. So what will happen is that this hydrogen atom will combine with one chlorine atom. This hydrogen atom will combine with the other chlorine atom, so that what we will have here is hydrogen combined with chlorine to form hydrogen chloride. And you see what is happening here? It is combining with chlorine by sharing electron, this one electron and this one electron. Now hydrogen is stable, it has 2 electrons, the last energy level, which is hydrogen only has 1 energy level, therefore with 2 electrons it's stable. Chlorine has now 8, it is very stable. I know you remember that. Another hydrogen, this hydrogen combines with chlorine, therefore what we form is another hydrogen chloride here. Now, and that is why we are saying, look at this, the equation. We have chlorine molecule, Cl2, 2 chlorine atoms, plus 2 hydrogen atoms. When they combine, or when the bond is broken and we form the atom, the individual atoms, this atom combine with this one to form hydrogen chloride. This atom combine with this one to form hydrogen chloride. How many are they? There are 2. And that is why you can see when a chlorine molecule combined with a hydrogen molecule, what we form is 2 hydrogen chloride molecules. Now what we are saying again is that when this bond is being broken, energy is absorbed. Plus energy. Energy is absorbed when the bond is being broken. Remember, it is this bond being broken. Anytime a bond is being broken, energy is required to break that bond. Now, that absorption of energy is what made us say that bond breaking is an endothermic process. Because energy is absorbed to break the bond. So this bond is also broken. When a bond is being formed, that is when hydrogen combined with chlorine to form hydrogen chloride, the bond that is being formed, or when that bond is being formed, energy is released. Is lost. That is why we give it a negative sign. So I want to believe by now you have understood the basics, that bond breaking, endothermic process, energy is absorbed. Bond formation, exothermic process, energy is lost, negative. Now assume we want to calculate the heat of reaction for the reaction between hydrogen gas and chlorine gas to form hydrogen chloride gas. Now in such a case, you will be given bond dissociation energies. And as we said, when a bond is being broken, energy is absorbed. So the values are given positive values, or the values are positive. So let us look at our reaction here. For us to be able to calculate the overall energy change, we must first of all determine the total energy that is required to break the bonds. We also must calculate the total energy released when bonds are being formed. So let us look at the bonds that have been broken. One of the bonds that has been broken is the hydrogen-hydrogen bond. Remember, all values on this side should be positive because bond breaking is an endothermic process. So let us look at the hydrogen-hydrogen. The energies that are given here are already the energy that are required to break the bond. So you just take it as it is, positive 436. Another bond that is being broken is the chlorine-chlorine bond. You take it as it is because that is the bond breaking energy, which is positive 244. You get the total. The total is positive 680 kilojoules per mole. Then you come to bond formation. Now, the bond that is being formed is hydrogen chlorine bond, but how many are they? According to this equation, there are 2. So you must always remember that the 2 are being formed. Then you come to the hydrogen chlorine bond. It is positive 432. But now this is the energy that is required to break the bond. But bond formation is exothermic. Therefore, you take the same figure. What I want you to know is that the same energy that is required to break a bond is the same energy that is required to form, that is released when that bond is formed. Let me repeat that. The same energy required to break a bond is the same amount of energy that is released when the bond is being formed. So ours will be negative 432. You give it a negative sign because energy is being released, and then you multiply that by 2 because there are 2. Therefore it gives you negative 600, no, not 600, sorry, negative 864. Negative 864 kilojoules. So the total energy released is negative 864. So what you do, you take the 432 that you're given, and if it is the bond that is being formed, you give it a negative sign. Again, remember, if 2 molecules are being formed, you must multiply because this is only for one bond, hydrogen chloride bond for one molecule, but we are forming 2, so you multiply this by 2 to get the total energy that is released when 2 molecules are formed. So you get negative 864. Bond, or rather heat of reaction is equals to bond breaking energy plus bond formation energy. Bond formation energy. Therefore, it is equals to bond breaking energy 680 positive plus bond formation energy negative 864. So that is 680 minus 864. That gives you 680 minus 864. That gives you an overall negative energy of 184 kilojoules per mole. Therefore, the overall energy for this reaction is negative 184 kilojoules per mole. However, this is the energy that is required to form 2 molecules of hydrogen chloride. What if you want to form only 1 molecule? So this one is, you divide this one by 2, by 2, by 2, by 2. The overall you divide by 2. Therefore, what you'll have is a half hydrogen gas plus a half chlorine to give you now 2 divided by 2, that is 1 hydrogen chloride. The overall energy for that reaction is negative 92 kilojoules per mole. So if you want to form only one, you take this one, divide by 2 to get the energy change for 1.